stuff, amazing stuff. All right, guys, we're going to jump right into it because this particular section, we only have 2 lessons to get through the hyperbola. And I know that the hyperbola is like a bit of a mind for other people. So we're going to try and take it as slowly as possible. If we can, we still need to finish in time, but I think you guys are going to get this one because when we break it down, it becomes a lot simpler when we look at what it is. First thing we're going to look at is the basic hyperbola. All right, so this is y is equal to 1 over x. Who can tell me why we've got 2 graphs? Why do I have a red graph up here and another one down here? Does anybody know why? You can pop your answer in the chat. You can raise your hand. I'll give you guys a hint. Something funky is happening here is why. Something funky is happening over here and something else funky is happening over there. Yes, Abednego says, because it's a fraction, you are right, but why is it being a fraction a problem? Explain to me why having it as a fraction is a problem. What do you guys think? Okay, I'll give you guys a hint. Because x is a function, yes, Katleho, wonderful, because of an asymptote. Okay.
Woo! My people.
You guys, I'm sure you guys already know what an asymptote is by now. If you've already done your parabolas, now we're looking at the hyperbola, there's also an asymptote in the parabola as well. But this one gives us a problem when we get to the function of x here. X cannot be a specific number. Can anyone tell me what x cannot be? If x is a specific number, we're going to have a huge problem. It's on the graph. I promise, guys, it's on the graph. Does anyone know? Exactly, Babalo and until actually exactly everyone in the chat. Yes, x cannot equal to 0. Okay, x cannot equal to 0. Okay, I'm going to take this a little further and not just x. Okay, not just x. The denominator, the whole of the denominator. My English is going. The whole of the denominator cannot be equal to 0 in a hyperbola. And the reason is because as soon as x is equal to 0, we have an undefined function. Okay, and that's what happens. And that's why we get a split at exactly this point over here, where x is equal to 0. Right there. So the graph splits into where x is equal to 0. But my graph also splits at y is equal to 0. This way as well. You guys see that? Going this way, my graph also splits. That's because at that particular point, my x and my y values do not align. Now, let's say, for instance, we wanted to find the intercept. Okay. Do you guys know what an intercept is? When I want to find my y-intercept, I need to make x equal to 0. And if I want to find my x-intercept, I need to make y equal to 0. Right. If I want to find my x-intercept, then my y will equal to 0. But this is going to give us a problem, actually 2 problems if we think about it. If I make x 0, my function is immediately undefined. So that one doesn't count. We don't have an x-intercept. What happens if I make my y 0 to calculate the x-intercept? Let's see what happens. If I go 0 is equal to 1 over x, and then I try to solve for x. Now, to get x out of the denominator, I'm going to have to multiply the side by x, multiply the side by x, right? And that would get rid of the x's, okay? And then x times 0 is going to give me 0. And on this side, I'm going to have 0 is equal to 1. This is a false statement. 0 and 1 are not equal to each other. And that's why we also have this line here where our graph splits, because at that point, our graph also doesn't exist. 0 is not equal to 1. Okay, that is why we have 2 separate graphs. We always have graph 1. I can call it graph 1. It won't really matter which one is graph 1 and graph 2. So we'll always have 2 separate graphs when we're looking at a hyperbola. Okay, So we have two asymptotes. Remember when we were doing parabola, or when you did parabola with teacher Peter, you had one asymptote after the turning point of the parabola. When we're looking at the graph of the hyperbola, you're always going to have two asymptotes. Okay. All right, so I'm going to give you guys a quick list of things that we need to remember to look for, because what we're actually going to be doing in today's lesson is we're going to be sketching a parabola. Okay,
fun stuff.
Sketching it. And when we're sketching it, we're always going to be looking for a couple of things. Okay, the first thing that we're going to look for is the quadrants. Right. I hope you guys remember where the quadrants are. I'm going to move this over to this side. Quadrants. Okay, your parabola, your hyperbola, I hope I don't say parabola anymore, it's a hyperbola. Your hyperbola will always either be in the first and the third quadrant, or it's going to be in the second and the fourth quadrant. Okay, so this one that we have here, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 over here. So this particular graph that we're looking at over here is sitting in quadrant 1 and quadrant 3, not 2. No problem, David, welcome.
No problems.
Okay, and when we're looking at it being in the quadrants, this is always going to be told to us by this particular number over here. Now, if you remember, y is equal to, this is the standard parabola form, a over x. I'm just putting a over here because this particular number doesn't have to be 1. It doesn't specifically have to be 1. It could be 2, or it could be 3 or 4, or -1 or -2. But when a is positive, when this number over here, the number above the denominator is positive, your two graphs are going to be in quadrants 1 and 3. And when your a over there is negative, your two graphs are going to be in quadrants 2 and 4. So my graph is going to look like that. Okay, it's going to look like that. So in these two, this graph and that one, my a is going to be negative in those two graphs. Okay, so what we're going to look at first is the quadrants, and then we're going to look at, oops, sorry. Okay, then we're going to look at our asymptotes. Okay, and for our asymptotes, remember, in order to find our asymptotes, we're going to look at where x cannot, or where the denominator, oh, let me not lie to you guys, the denominator, okay, the denominator is not equal to 0, because that will make our, see, that's the exact kind of jokes I love, Yolanda. My love for you all is like dividing by 0. It can't be defined. See, you're
Love all of you.
My denominator cannot be 0, and then we need to look at where our y is moving. So our y is going to either move, or the vertical shift in our y, the vertical shift. Okay, and all of this is I'm going to be able to explain all of it in just a little bit when we actually start drawing. Okay, and then number 3, we're going to look for the intercepts, if there are any. Remember, when we are thinking about intercepts, we want to find the x-intercept, where we make y equal to 0, or I'm just going to shift up a bit here, or our y-intercept. My handwriting is terrible. I'm so sorry, where x is equal to 0. But Coco, you just told us that we are not going to get a place where x is equal to 0. Okay, hold on. We are, just not yet. Not in the first few examples that we're going to be doing. But when we shift our parabola, we are going to be able to find intercepts. So for now, I just want you guys to remember these 3 things. We're looking for the quadrants, where a is either positive or negative, the asymptotes, where our denominator cannot be 0, and where our y has a vertical shift. And number 3, our intercept, our x-intercept and our y-intercept. Can I just get like a thumbs up or a thumbs down from you guys? Let me know if you guys are with me. Are you guys understanding me? Is anybody kind of lost a little bit? Make sure that you guys are still with me here. Okay, awesome stuff. Okay, Lesedi is giving me a thumbs down. Lesedi, would you like to maybe pose a question in the chat or raise a hand so we can, Sarah says, okay, all right. If you're still confused, if you're still a little confused, like 50-50, we're gonna look at an example. We're going to look at an example now, and we're going to see how these three things actually come into play when we are trying to sketch the graph of a parabola. Okay. Oh, a hyperbola. If I say, please, you need to remind me.
I'll remind you.
Hyperbola.
I'll remind you. And guys, you're doing really well. Remember, that is the first time you're learning. So as time goes by, you'll feel good about it.
Yeah, we'll feel a lot better as we go along, but I'm glad to see so many. Lesedi says he just logged in, so he's a bit lost. Okay, we're going to take it a step at a time, Lesedi. So just hold on for me. We're going to be looking at this particular function over here. Y is equal to -1 over x minus 2. And what I want you guys to do for me is find number 1. Find me the quadrants. You can pop the answer in the chat for me. Find the quadrants for me. Number 2, find me your asymptotes. And remember, number 3, okay, number 3 is your intercepts. And yes, in this particular one, we are going to have an intercept because my graph has shifted. And we're going to talk about how my graph has shifted. Laredo is like, 2 and 4, 100%. Okay, explain to me why you say 2 and 4. Don't just say 2 and 4. Explain to me, how did we get to 2 and 4? Why do you guys say 2 and 4?
Come on, my people. We can do this. Let's
show you guys know. A is less than 0. A is negative. Well done, Nyangezi. Yes, 100%.
Nailed it.
Because A is negative or A is less than 0, you'll find that they write A is less than 0 a lot. Oh, okay, I don't like that. I don't like that color. Okay. In your exams and in your tests, they'll probably write A is less than 0, but anything less than 0 is just negative, and that's what they mean in this case. Okay, A is less than 0, A is negative. Therefore, okay, that means we are in quadrants 2 and 4, which means my first graph is going to be here somewhere, and the other one is going to be here somewhere. Remember, Katleho, this is A, this part over here. Okay, remember the original form of the graph is A over X, and I know there's something missing here. We're going to get to that something missing in a little bit. A over X plus or minus Q, and the Q in this case is going to be our vertical shift. All right, what about my asymptotes? Okay, who can tell me? Give me my 2 asymptotes. Remember, my denominator cannot be 0, so I'm going to have 2 asymptotes where X is, or where my denominator is. X cannot equal to 0, Nkanyezi says, X cannot equal to 0, and Y cannot equal to -2. Are you guys, do you guys agree with Nkanyezi? I don't want him to just tell you guys things and you're like, yeah, okay, I guess. Okay, I hope the rest of you guys are understanding when Nkanyezi is getting all of these answers. Okay, if you're lost as to how we got that Y is equal to -2, remember, if I'm going to find my intercepts and I make my X, if I make my Y 0, my X is then going to equal to -2, which won't work. All right, Dawn, let's do this one quickly, okay? So I know that my 1 asymptote, I know that if I do this, if I go -1 and I make X equal to 0, this is going to be undefined. So this doesn't exist already, okay? That's how we know that X cannot equal to 0. That's the first thing. But if I make Y 0, I'm going to have 0 is equal to -1 over X minus 2. And then I'm going to take this over. 2 is equal to -1. Oh, actually, I'm calculating for the intercept here. Over X. Okay. And then I'm going to multiply both sides by x, both sides by x. Those two will cancel. I'm going to have 2, x is equal to -1, x is equal to -1 over 2. This is the intercept, sorry. X is equal to -1 over 2. All right, so the vertical asymptote, hold on. Okay, the vertical asymptote over here. Okay. Oh, did I just erase my entire graph? There we go. Okay. Not the vertical asymptote, the horizontal asymptote. Okay, just let's say, for instance, this didn't exist for a little bit. Hey, Dawn. Okay, now if I make y 0, I'm going to get -1 over x. And then if I multiply this side by x, like I just did, and I multiply this side by x, those two will cancel. And then x times 0 will give me 0 is equal to -1. And that doesn't exist. So my y-intercept, or not my y-intercept, my y-asymptote is going to be that number there. The one that makes sure that I get an answer for y. Okay. Are you with me here? Are you understanding where I'm at? Can I get a thumbs up or a thumbs down? Okay, I'm going to wait for that thumbs up or thumbs down from you. Yes, so the y asymptote is -2. Okay, David? Okay, I'm getting thumbs up. And again, somebody named Zoom user is saying, oh, David says, come again. Okay, so David, look here. If I'm looking for my x-intercept or my x-asymptote, right, x cannot be equal to 0. Okay? Because when x is equal to 0, this whole thing becomes undefined. Okay. Now, when I'm looking for my y-intercept, okay, I'm going to park this for now. I'm going to take that out. So I've got y is equal to -1 over x. Okay. Now, if I want to solve for the x-intercept, I'm going to make y equal to 0. So 0 is equal to -1 over x. Now, if I have to solve for x, I'm going to have to multiply. I'm going to have to multiply both sides by x. So I'm going to multiply this side by x, and I'm going to multiply this side by x. Okay, this is getting kind of tricky here. I need to move that out. Okay, so if I multiply both sides by x, those two x's will cancel, and x times 0 is going to give me 0. And then over here, I'm going to have -1 left. And 0 and -1 cannot, these two things are not equal to each other. So the only way I get an answer for y is if that -2 is included. And that's where the asymptote for y comes from. And Dawn says, does that mean that the y asymptote is equal to q? Thank you very much. You got to the exact answer that I wanted you to get to. Yes. So this q over here is your y asymptote. Oh my goodness, if I have to delete this one more time. I'm sorry, guys. Okay. David, I hope that answers your question. Okay. Dawn, the y asymptote is this q that we've got over here. Okay. I'm glad. Okay. All right. So if I had to sketch this graph, okay, if I had to sketch this graph, what I'm first going to do is I'm going to remember my two quadrants, quadrants 2 and 4. So I know my graph is sitting on this side over here, and this side over there. I'm going to delete these two in just a little bit. And then I'm going to look at my asymptotes. I know that my x cannot be equal to 0. So my graph will not be able to touch this line here, or my graphs, because they're two graphs. And then my y asymptote is -2. So I'm going to go to my y-axis and go to -2 over here. And I'm going to draw my asymptote. Okay. Then I know that my one graph sits on this side. This one doesn't really matter over here. Okay. And then my other graph will sit on this side. But remember, because we have an intercept, that x goes, oh, this point over here, x is equal to -1/2. I'm going to have -1/2. And to get my intercept, I had to make my y equal to 0. So this point here, where the graph crosses this line here, this is -1/2 and 0. Okay, just there. All right, guys, are we okay with this particular example? Okay, can I get a thumbs up or a thumbs down? Okay, I'm getting a couple
I trust my people. I trust you guys. Oh, well done.
Okay, good
That's
stuff.
amazing.
Right. I want you guys to try the next one. Remember, I want you guys to try and draw it with all its intercepts and the such. Okay, and remember that we're looking for 3 things. We're looking for the quadrants, the asymptotes, and the intercepts. Okay. Barbara, if you're still a bit lost, try and follow along. Babalo, try and follow along this time. Remember the 3 things that we're looking for. Okay. Number 1, we're looking for our quadrants. I'll just write them out over here. 2 asymptotes. And 3 intercepts.
Let's do this, guys.
Okay, remember, first clue, this is already your y-intercept. Okay, Cameron says quadrants 1 and 3 with a question mark. Are you asking me or are you telling me where it is? I hope you're telling me rather than asking me. Why do you think it's 1 and 3?
You can do this, Cameron.
And yes, you are right. Yes, because A is positive. Thank you, because this number is positive. Very well done. Because A is positive or because A is greater than 0, we're going to have it in quadrants 1 and 3. Okay, Lesedi, because I think you were like just a few minutes late, you missed the part where we talked about quadrants. Remember this number over here. This number above the denominator is going to tell us where our quadrants are. So if that number over there, which we can denote as A, if it's positive, our graph is going to be in quadrants 1, not 1/3, 1 and 3. It's going to be in quadrants 1 and 3. And if that number over there is negative, then our graphs are going to be in quadrants 2 and 4. Okay, so remember, when we look at a Cartesian plane, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this one is positive, so it's going to be in this quadrant here and in this quadrant here. Okay, good. Who has my asymptotes for me? I know you guys can give me the first asymptote already. Who can give me the y asymptote? It's the easiest one. Actually, they're both quite easy in this one. Good, good. My y asymptote. My y asymptote is at 3. And my x asymptote, what about my x asymptote? That one would be just as easy, I believe. There we go. Dawn says x is not equal to 0 and y isn't equal to 3. Okay, great. X cannot be equal to, or the asymptote is that x is equal to 0. Excellent stuff. I see somebody's already calculated the intercept for me. Remember, if I want to find my y-intercept, it's not going to happen because I'd have to make x equal to 0. And we already know from up here that x cannot be equal to 0. So I don't have a y-intercept, but I do have an x-intercept. And when I want to find my x-intercept, I need to make y equal to 0. So my new graph is going to read 0 is equal to 2 over x plus 3. And then we can calculate, I just want to move up a little bit here. Okay, and then we can calculate for x. I'm going to take 3 over and I'm going to get -3 is equal to 2 over x. And I'm going to multiply both sides by x. Multiply by x, that's going to give me -3x is equal to 2, because those 2 will cancel. Therefore, I'm just going to write it over here. X is equal to 2 over -3. Dawn says, ma'am, should the sign for the asymptote be equal or not equal to? You can make it y is equal to 0 because you've already named it an asymptote. You don't necessarily have to say it's not equal to. It's just that if you say that it's an asymptote, then you don't have to write the not equal to sign. You can just say y is equal to 3 because that is the asymptote you're telling us about. Okay. All right, exactly the way Yolanda's written them down there. The asymptotes are y is equal to 3 and x is equal to 0. The only reason I put like little marks through them is because I just wanted to remind you guys that x technically can't be equal to 0. Okay, so now if we have to draw this, okay. Oh, just a quick reminder, this is actually a coordinate on the Cartesian plane. It's -2/3 and 0. Okay, now if I have to draw this, I know I'm drawing in quadrants 1 and 2. I'm going to start with my asymptotes. So I know that this whole line, that whole line there, I know you guys can't see it, but I'm going over that line there in blue. That whole line is one of my asymptotes, and then y is equal to 3. So I'm going to go up at 3, put my dots there for my asymptote. Okay, and then I remember that my graph looks like that, all the way over top over there. And on this side, my graph looks like that. And this point here that touches the x-axis over there, that is the point -2/3 and 0. Okay. All right, guys, I hope this is helpful. We're going to do one more before we do a brain break, and then we're going to shift the parabola to the left or to the right. Oh, no, we're not. No, we're not. Yes, it's actually time for the brain break. I know why, because I added one more. I added another one in the shifted parabola, so we're going to be looking at that one in a little bit more detail. All right, I want you guys to tell me if you can figure out what these brain breaks mean. Cameron, I'm glad you're happy to see the brain break. I'll give you guys an example. This is called a rebus puzzle, and this, because there's a line over here over this is actually me saying over my dead body. Okay, yes, there we go. You've got it, over my dead body. Okay, I want to see if you guys can figure out. I want to see if you guys can figure out the other 3. Okay, the last one is quite difficult. It took me a while. Oh, head over heels. Well done, guys. This one is head over heels. Yeah, and the last 2 are really difficult. I won't lie. Oh no, Abednego, you're making it. Okay, the reason I'm saying they're difficult is because it took me a while to figure them out.
Abednego is like, nah, I got this. I got this.
So I've got like 1 meter, 2 meters, 3 meters, 4 meters. This is actually a metaphor. Okay. And then Chantal says, do what you must. No, not quite. This one was difficult, I won't lie. This one over here is quite difficult. And Nyakenzi just
oh, wow. These people are good.
This one is,
are you guys Googling these answers? Because I'm looking at them and I'm like,
I feel like
this is so difficult.
Google. Oh, no, wait. No, what goes up?
What must go up must come down.
What goes up? Yeah. What goes up must come down. That's this one.
Wow. I wouldn't have thought of that. I'm sorry.
I know, it was quite. It was
going to take me a while to get the answer.
Oh, this one.
Ah.
This one is quite difficult, though.
Lee, where do you get BODMAS?
No, Lee, I don't think it's BODMAS. I don't think it is. This one is quite difficult. It took me a while to get.
Oh, Lee is so productive. Like you so what do you call it? When someone is, what is the word in English? Oh.
I would say random. Yeah. Oh, Abednego, don't just say no idea. Keep thinking. I'll give you guys a clue. This is the number 1, and it's sitting between an M and a Y. Lerato, no, but Cameron, almost there. For my life, you're on the right track. It does have something to do with the word for.
Is it we only live once?
Maybe something. No, it's okay. It's not you only live once.
Yes, see, I can't get it also.
Okay, this one is quite difficult. This one is actually the only one for my life.
Ah!
Yeah, so there's 1, 2, 3, 4 ones, but there's only one of them in between M and Y. So the only one.
Wow.
I know, it was tricky when I saw it myself as well. Yeah.
Wow.
Yeah. Okay, so these are called rebus puzzles. You are very close, Cameron. Very, very close. Okay, guys, these are such great for like stimulating your brain and helping you think outside the box. There are like millions of them on Google and on the internet. Please don't go look at them before. You can look at them after Wednesday, after we've had this lesson, because I have more of them on Wednesday.
Now we know where you're going.
Dawn was like, you only live 4 times. I wish I could live 4 times, Dawn. I would do so much. Okay, so guys, this was our brain break. I'm going to give you 1 more minute to just stretch, stand up, do a little husa. I'm going to stand quickly because I've been sitting for quite a while. Just a bit of a stretch before we start looking at our
Let's stretch, guys. I see you, Bali, I see you go. Do some movement over there. It's good for you.
Sure. All right.
That was
Cameron,
good.
I love that you love this brain break. I have many, many more. This is what I do in my free time. I'm a nerd like that. So yeah. All right. Awesome stuff. Okay. I hope we're all ready to move on.
Yeah.
Okay. All right. Now we're going to be shifting our parabola a little bit. And this takes a little bit more work than just what we were doing now. And I know I've got a lot of stuff on this page at the moment, but do not panic. Do not panic. It's not as scary as it looks. Okay, we just need to remember the first 3 things that we learned. Okay, first thing we learned about was the quadrants. Okay. Look at the quadrants. Number 2, we looked at our asymptotes. And number 3, we looked at our intercepts. Okay. Now, guys, remember what I said at the very beginning of the lesson. And those of you who are not here at the very beginning of the lesson, I'm sorry, I'm going to repeat myself. Instead of saying that x cannot equal to 0, I said to you guys that the denominator, the whole denominator, okay, ooh. Okay, let's write that properly. The whole denominator cannot equal 0, okay? And the reason why I'm putting it as the whole denominator is because if I go down here and I make x equal to 0, if I make x equal to 0 over here, I'm still going to get an answer for y. My y is just going to give me 2 over 0 plus 1 will give me 1 plus 2, and my y is just going to equal to 4. Okay, and that means that x equal to 0 is not an asymptote. Okay? It's not an asymptote. So in this case, this whole thing over here needs to equal to 0 in order for this to be an asymptote. Okay. Can I get a thumbs up or a thumbs down? Are you guys understanding what I mean when I say that the only way that part is going to be an asymptote is if the whole denominator is equal to 0? Okay, Cameron is still a little bit confused, but I'm going to just completely just destroy that right now, and you're going to be like, oh man, absolutely, I see it. It's amazing. Okay.
Yeah, definitely.
So here in the last question that we had over here, okay, in the last sum that we have over here, x over here, x could not be equal to 0. Because if x is equal to 0, this whole thing is undefined, right? Therefore, 0 or x is equal to 0 is an asymptote. That makes sense because we know that if we make that 0, that whole thing is not going to play. Now, if I go over here to this sum, if I make x equal to 0 here, let me rewrite the whole thing. Y is equal to 2 over 0 plus 1 plus 2. 0 isn't giving me a problem anymore. 0 is not giving me a problem because I can solve for this. This is just going to give me 2 over 0 plus 1 is 1 plus 2, which is equal to 2 plus 2, which is equal to 4. So my y is then going to be equal to 4. The number that would give me a problem here, who can tell me what number can x not equal to over here? Which number would give me an issue? Oh, and I did it again. There we go. I see a lot of negative ones. Somebody said 1. Please just make sure that you're checking yourself before you get there. Cameron, hold on. Okay, we're going to have a look. You guys are 100% correct. Yes, Cameron, it's -1. Okay, because if I put -1 in here, -1 plus 1, this is going to give me 0. And then my new sum looks like y is equal to 2 over 0 plus 2. And then this whole thing becomes undefined. Okay, so in this case, my x asymptote changes because my graph moves. Okay. But everything else stays exactly the same. Nothing else changes. Okay. We're still going to look for our quadrants, we're still going to look for our asymptotes, and we're still going to look for our intercepts. But how many intercepts are we going to get this time? We're not just going to get one intercept. How many are we going to get? Who can tell me? It's a very simple answer, guys, I promise. Very simple. Yes, Nkanyezi, we're going to get 2 asymptotes because x can be 0 and y can also be 0. Very well done, Ovayo. Okay, so we're going to try and draw this one. I'm going to give you guys like 3 minutes. Okay, I want you guys to remember the 3 things that we're looking for. Number 1, give me my quadrants, please. Give me my quadrants. Number 2, give me my asymptotes. And number 3, give me my intercepts. And this time, there will be more than one. Hey, Ovayo says 2 and 4. Ovayo, always tell me why. Ovayo says quadrants 2 and 4. Give me your reasoning behind that. Cameron says 1 and 3, and now I don't know who to trust. Who am I trusting? Well, is it? Oh, yes. Cameron says quadrants 1 and 3, because A over here, which is actually our 2 on the graph, is positive. Our A is positive, therefore quadrants 1 and 3. Excellent stuff. Well done, guys. All right, give me my asymptotes. Remember, my asymptotes are not going to be that easy. The only one that is easy is my y asymptote, because I already know that that number over there is my asymptote. Remember, Dawn, you can just write x is equal to and y is equal to. Okay, you don't have to complicate it. Okay, Monique says y is equal to 2. Thank you very much. And what about my x asymptote? We literally just did it. We just did it. And Monique says x is equal to -1. Okay, and then I'm going to give you a minute to calculate for your intercepts. Okay. Barbara, remember this one over here, this Q over here, this is our y asymptote. This is our y asymptote, the Q value. So in this graph that we have over here, your asymptote, your y asymptote is going to be 2. And then in order to get our x asymptote, we need to see which value of x is going to make this whole denominator equal to 0. So what must I replace x with to get 0 over here? Excellent stuff, Cameron. Well done. Awesome. Awesome. I'm glad. Okay, Dawn is giving me x is equal to -2, y is equal to 4. Dawn, are those your asymptotes or are they your intercepts? Remember, your intercepts need to come in the form of coordinates. So I need to get x coordinate and 0, and then 0 and a y coordinate. So I should have something like that and 0, and I also need 0 and something. Okay, because those are 2 points that we actually put on the graph. Well done, Loreto. That's one of them. There we go, Dawn. Excellent stuff. Okay, I'm going to double check you quickly just to make sure. I know you're correct, but I still need to do the math to make sure that we're all on the same page. Okay.
Well done, my people.
I'm not doubting your skills. I hope you know that.
It's to show others. It's to show others how we got to the answer. So it's very good. Okay,
there we go. Okay, so I'm going to take the positive 2 over. That's -2 is equal to 2 multiplied by x plus 1. -2 multiplied by x plus 1 is equal to 2. This is going to give us -2x minus 2 is equal to 2. -2x is equal to 4. Therefore, x is equal to -2. Good. So this first coordinate over here is going to be -2 and 0. And then I'm just going to squeeze over to the side a little bit, and then we're going to calculate for the y-intercept. Y-intercept where x is equal to 0. So I'm going to have y is equal to 2 over 0 plus 1 plus 2, which is equal to 2 over 1 plus 2, which is equal to 4. So that means my y-intercept is going to be equal to 0 and 4. All right. Okay, now we're going to plot all of this onto the graph. So I'm going to have this in quadrants 1 and 3. I'm going to start with my intercept. My x-intercept is no longer on that line, not my intercept, my asymptote. My x-asymptote is no longer on that line. It's sitting at x is equal to -1. So over there, just like that. And my y-intercept is sitting at 2, all the way over there, at 2. Okay, and again, because I'm in quadrants 1 and 3, that means my graph is going to go like that. Okay, and like that. Okay, and actually, this should keep going up. I'm going to just extend that because over here, we have the point 0 and 4 on our y-axis. And over here, we have the point -2 and 0. All right, thumbs up if you got all of that correct, including the drawing. Are we all comfortable with this? I'm getting thumbs up. Awesome, awesome, awesome. I'm so glad, guys. See, guys, I told you this stuff is easy. I think it looks difficult, but it's not really difficult at all. Okay. Awesome stuff. All right, we're going to try one quick one before we have to go. Cameron says 85. I think he means like he's at an 85% maybe. I'm not sure where you're at.
Still good. Still good. Well done.
85% is so good. Okay. I remember now my dad, every time I come home with an 85, he'd be like, what happened to the other 15? I won't be saying that to you.
Damn.
85 is good. 85 is really good. Oh, he stepped on his keyboard. Okay, be careful. All right, we're going to try one more before we head off. Okay, we're just going to try this one quickly. I think we also have to run a poll today. So guys, remember our 3 things that we're looking for. We're looking for quadrants, asymptotes, and intercepts. Go for it. That's okay, Dawn. As long as it's all coming back to you, that's great. I'm glad that you're with us and you're able to help us here. All right. So I'm seeing quite a few answers for quadrants. Then number 2. Actually, let me move this up. Oh.
Yeah, our screen went blank.
I know, I have no idea what just happened. Oh, there we go. Oh, I must have clicked something. I'm very sorry, guys. Oh, my own screen. Okay. Guys, Barbara is asking what determines the quadrants. Who can help her? How did you guys know that the quadrants are quadrants 2 and 4? Who can help her?
Just a reminder to everyone that this lesson is being recorded, so you are more than welcome to go and check it out after 24 hours.
Yes, awesome. Okay, excellent. I'm seeing because our A is negative, our quadrants are going to be 2 and 4. Thank you guys so much. You're being so helpful. I'm seeing all of this. If A is negative, then it's quadrants 2 and 4. And if A is positive, it's quadrants 1 and 3. I'm very glad that you guys have been listening. I feel so honored. This is great. You guys are taking in everything I'm saying. It feels awesome. All right, let's talk asymptotes. Y is equal to, or X in this case, if this has to be equal to 0, then X cannot be equal to 2. So our asymptote for the X value is going to be 2. Okay. And our Y asymptote is always this Q value over here. So Y is equal to -1. Okay. Dawn, if A is equal to 0, then we don't have a graph at all because 0 divided by anything will be 0. Okay, so you won't have a graph, or you'll just have a graph of Y is equal to -1, which is just a straight line. Okay, so A can never be equal to 0. Okay, that's a good question though, a very good question. A can never be equal to 0. Otherwise, we don't have a function. Right, let's look at our intercepts. Y-intercepts, X is equal to 0. So it's going to be Y is equal to -1 over -2 minus 1, which is equal to -2 divided by -1 divided by -2 is 1/2, minus 1 is -1/2. So my first one is -1/2 and 0. And then we're going to calculate for the x-intercept. If we want to find the x-intercept, we're going to make y equal to 0. So we're going to get 0 is equal to -1 over x minus 2 minus 1. I'm going to take the -1 over. 1 is equal to -1 over x minus 2. Multiply both sides by x minus 2. That's just going to give me x minus 2 is equal to -1. I'm going to take the 2 over, therefore x is equal to 1. So those of you who got 3, I'm hoping you can explain to me how we got to 3. Andile, maybe check again. I'm going to get 1 and 0. Okay, so those are my 2 points. Okay, And let's check my maths. Maybe I didn't quite do it correctly, but I'm pretty sure I did it correctly. Okay, so I know that my graph is going to be in this quadrant. He forgot to change the sign. That's okay. And this quadrant over here. So I'm going to start with my asymptotes. X is equal to 2 over here at 2, and y is equal to -1. Oh, and my computer's going to die. Okay, I'll make sure it doesn't. We're going to finish just now. All right. And then my x-intercept is at -1/2 and 0. So it's going to be like there. Oh, I'm lying to you guys. Now I'm making 0 my asymptote, and that's not correct. This is what my graph should look like that. Okay, and this one over here, the other graph is going to sit on this side, and it doesn't touch the x-axis or the y-axis. This point over here is going to be 1 and 0, and no, other way around, Guys, you guys need to check me, 0 and 1, the other way around, 0 and 1. So this point over here is actually 0 and 1, and this point over here is -1/2 and 0. Okay, and I think that's it from us today, guys. Can I get like an out of 10? How are you feeling about this hyperbola section? 10 being I got this. This is excellent. 0 being, I don't know what's going on here. Dawn is asking, how do you determine the shape of a hyperbola? Most hyperbolas, Dawn, will always curve like this. And the reason they curve is because when we look at every single value that is valid for each of these graphs, we consider that this graph is getting closer and closer to our asymptote. It doesn't touch our asymptote. So it comes from here and it curves and it gets as close to our asymptote as possible, but it never actually touches. The same with this asymptote, with our x asymptote. It just keeps getting closer and closer, but it doesn't touch. So it has to curve at a point as it goes further away, and when it comes to the side as it goes further away. Okay, so the curve, it will always be a curve getting closer and closer to the asymptote, but never really touching, because at that point, both of them will be undefined. Okay, I hope that answers your question. I'm getting 6s and 7s. Okay, somebody's saying, ma'am, can you move the screen to the left a bit? There it is. I know my drawings are very ugly, guys. I'm sorry. I will work on my handwriting. Hopefully by Wednesday, I'll be a little bit better. Okay, I'm seeing 5s. And I'm seeing 7s and 8s. Ganyezi is like 10, loving it. I'm glad to see that you guys are feeling a little bit more comfortable. Katleho, we will get to that. I will address that on Wednesday. We will look at graphing again, and we'll look at plotting again. Okay, all right, guys, I think that's it. It's actually 7. Nizole says she started at a 3 and now she's at a 9. That's excellent. Thank you so much. Katleho, do you have a question? Hi, Katleho.
Hi, ma'am.
Hi.
Ma'am, can I just ask, so the 2 intercepts that we calculated, they're just for the one graph in quadrant 2?
Yes. So as soon as we look at, if you look at our intercepts, not our intercepts, sorry, our asymptotes, you find that the graph that's in part 2 doesn't even touch the x or the y axis anymore, which means that both intercepts need to go through that one graph. Okay. I hope that answers your question. Hi, Siyabonga. You're very welcome, Cameron.
I'm sorry, ma'am.
Hi.
Sorry to disturb you.
Not a problem.
In the intercept you got,
yes.
Isn't it if you want the y-intercept, you let x be equal to 0?
Yes.
Yes, I got that. But then in the graph, I don't know how to explain this. I think you switch. I think
You may leave, Nate, it's fine. Yeah. Okay.
in the y-intercepts, I think you wrote.
Okay.
Yes,
Let me just
zeros
check if
minus
maybe I haven't switched them around. Let me just
Yes,
see.
can you check, please?
Okay, x-intercept, y is equal to 0, and for my x-intercept, oh, you're correct. Yes, you see, thank you so much for correcting me. This over here.
A good eye over there.
Thank you very much. Yes, when my y was 0, so this should have been 1 and 0. Okay, so this should have been y, 1 and 0, and the other one should have been 0.5. So, okay. Let me go and interrogate this one, and I'll get back to you in the next lesson. I am going to see you in the next lesson, right?
Yes.
Okay.
Yeah,
right.
and guys, we will
Excellent.
I think we're
Excellent.
continuing
Thank you
with
so
this
much.
lesson, aren't we?
Yeah. Yes, we are. We're
It's
going
the
to
same
continue with the
topic.
very lesson